Okay, geometry, we are going to begin our quest, our adventure with proofs today, starting with something we've done before, which is equations, okay? In the postulate family are properties. Properties are statements that are mathematically true, kind of like definitions, but they oftentimes involve formulas, okay? And the addition property, we're just going to run through all of them here. The addition property is that if A equals B, then A plus C equals B plus C. Okay? If A equals B, then A plus C equals B plus C. Basically saying that if you have two things that are equal and you add the same value to both sides, they're still going to be equal. Right? If you have two things that are equal and you add the same value to both sides, they are still going to be equal. Okay? The addition property. The subtraction property. Well, you two were scooting your chairs back and forth.
Yeah,
that's why you're
not.
I'm with you, Schultz.
If A equals B, the subtraction property says, then A minus C equals B minus C. Same premise here, right? That if you have two things that are the same, stop.
What did I do?
Stop. You have two things that are the same, and you subtract the same value from each of them, it's still going to be equal size. You still have the same equal value. Okay? Also, notice these are written in if-then form. Okay? So they are conditional statements. Kind of go back to what we talked about in video 12. Can anybody guess the multiplication property? Andrea.
If A equals B, then A multiplied by C equals B multiplied by C.
If A equals B, then A times C equals B times C. If A equals B, then A times C equals B times C. Again, basically saying if you have two things that are the same, you can multiply them each by the same value, and it's still going to be the same. Going back to the golden rule for algebra, that what you do to one side of the equation, you do to the other, right? Think about opposite operations. When you solve for a variable, if your equation is 2x plus 5 equals 10, you subtract 5 from both sides, you're allowed to do that, right? Because you have two things that are equal. The subtraction property says you can take something away from both sides, and it's still going to be the same. Paul. Division property. Go ahead. If A equals B, then
A divided by C equals B divided by C.
What's the condition to this one, though? This one's got a condition to it. If A is B, then A divided by C equals B divided by C. Caitlin?
C is not equal to 0.
Right. In this case, C cannot equal 0. That is the one condition for
Why
this.
that?
Why can't it equal 0?
You can't divide by
Paisley?
0.
You cannot divide by 0.
I just figured it out.
You cannot divide by 0.
No, it's not.
So that C is unequal to 0 would be a counterexample here. It's the one instance where this property does not work. The substituted property, I want you to star this one. You are going to use this a lot in your proofs. Basically what we're filling out here, we're filling out all the reasons you can use to defend your solving any equation. So when we get to proofs down below here, we'll have a statement column and a reason column. The reason is your evidence. It's your logic. You explain your steps. These are all reasons you can use. Okay? Any definition, property, postulate, theorem, all those things are accepted reasons. This one, the substitution property, you're going to use a lot. Okay? And it says, if A equals B, then A can replace B in an equation or expression. I should put 2 lines for that one.
That's what I was.
Yeah. If A equals B, then A can replace B in an equation or expression.
I don't think we need another line. I don't think we need another line.
No?
You ain't
I
small.
fit it. I fit it.
Great.
Well,
Way
like,
to
they-
adapt.
Great small.
Way
Thank
to adapt.
Well, I knew that, but like.
Finally, the distributive property. If, well, hold on.
Is it not gonna be?
This isn't really an if then statement here. The distributive property says A times the sum of B and C is equal to A times B plus A times C. Think of when you do the little arrows into parentheses, right? You distribute something, right? This is what this property describes, basically. If you have a coefficient, two parentheses, you can distribute that A in, right? And it becomes A times the first term plus A times the second term. Okay. Do you have a question, Paul? Okay. Anyone else still need some time? You will have some homework, yes. All right, let's do some proofs. Here we go. If you don't understand yet, I think you'll see it. It's okay.
I don't.
We were just filling out our reasons. I was giving you what you can use to argue and logically solve an equation. Write a proof. The first thing to know about proofs. Yes,
Dude.
Nathan. You got to do it anyway. I think you'd much rather do it with my instruction rather than trying to read through your book and trying to figure it out on your own. If you disagree with that, feel free to leave. Mrs. Napoli's office is open. Otherwise, I do not need those comments. Paul,
Schultz, if that was me, I would take the hall.
do you want to go in the hall?
No.
Well, then be happy it wasn't you. Okay,
I'm just saying.
4 plus 8x equals 10x minus 10. We're going to solve for x using proofs here. And every single proof that you will ever write has to start with what you know. What we know is that here, I kind of jumped the gun here. We're going to make a statement and reason chart. Okay? So on the left side, make a table that says statement and reason. And your first statement is always what you know. What we know is what we are told. 4 plus 8x equals 10x minus 10. That's what we know. And your reason for this is given. Every proof starts with a given statement. This is what we are told. From here, it's our job to solve for x. Okay, using these mathematical properties. Yes?
X equals 6.
Thank you, Brielle. So, thinking about opposite operations, travel back in time to algebra, what would your first step be here? What would you think to do first to solve for x in this equation? Cormac,
Isolate variables.
what would your first step be?
I subtracted 8x from the left side and added to the.
Okay, and that act of subtracting 8x in algebra, you had to show minus 8x, cancel it out, write the new equation. In geometry, you don't. If we subtract 8x from both sides, we can say that 4 is equal to 2x minus 10.
Oh, that's
Right? The work is subtracting 8x from both sides. Okay, and I'm going to write it in here just to prove a point. You don't have to.
4 equals what?
But what mathematical property did we just use to get from step 1 to step 2? Paul?
Subtraction.
Subtraction property. Why?
Because we had to get the variable on one side.
Okay, and what did we do?
Subtraction. The subtraction.
We subtracted the
8.
same thing from both sides,
Oh, yeah.
right?
The same thing for both.
4 plus 8x is like our A. 10x minus 10 is like our B. We subtracted C from both sides, which is legal to do. Okay? So your second reason, instead of showing work, like in algebra, in geometry you have to explain what you did. And what you did was you used the subtraction property. Or if you want to abbreviate the subtraction prop. Or if you really want to abbreviate the subprop. But make sure you know what sub stands for.
Substitution.
Okay?
Exactly.
Number 3, what would your next step be here algebraically to solve this? Sam? Add 10 to both sides. You don't have to write this. I'm just going to write it to prove a point. Okay? What you would need to write is step 3. We now know that 14 is equal to 2x. Because if you're doing geometry, it's understood you've mastered algebra. once you master algebra, you don't have to show every piece of work because someone reading this should know what's going on if they're following a geometric proof. But you do need to explain what you did. Sam, how can you defend the action of adding 10? Addition property, because you added the same thing to both sides. That's what the addition property is. All right?
Yep.
And what would our next step be?
Solve for x.
How would you do that?
2 divided by 14.
Other way around,
Yeah.
right? Algebraically, you would divide by 2. You don't have to show the work. All you need to write is that in step 4, you can conclude that, good job, Gabrielle,
Thank you.
7 is equal to x. Okay? And Nicole, how would you defend that step of dividing both sides by 2?
Wait. Oh, no. Division property.
Division property.
Yeah, I got it.
Okay? So, I mean, you've been doing this all throughout algebra. We called it opposite operations because algebraically that's the method that's being used. But mathematically, geometrically, what's going on here, right, is that we're using these mathematical properties. Why can we subtract 8x from both sides and have it be the same? Because of the subtraction property. That's your defense. That's your evidence. Okay? That's your logic process to do this. Does that make sense?
Yeah.
Okay?
Are we done?
No, we're not. Well, we're done with this one.
Yes.
Okay? Next one. How do we start?
No clue.
How do we start? Brielle.
Put the equation.
So start with your statement and reason chart. Okay? This one I might leave myself a little more space on the statement side because the equation is a little bit longer. Right? And our first step, our first thing is what do we know? We know that 7 minus 12 times the difference of n and 4 is equal to negative 18n plus 37.
Wait, hold up.
Okay? We know what we're told, which is the equation. And just like every other proof you're ever going to write, your first statement, first reason, Riel,
Put the 12 in the parentheses.
given. Good job, Riel. Okay? The first reason is always given. You know this because it's given to us. It's information we are told.
Good job, Rio.
Okay? Information we are told. This is like the opening statement of a trial, right?
Order.
This is what we're told. Now we have to make our conclusion based on the evidence, right? Brielle, go ahead. Take step 2. Your time to shine here.
Multiply the 12 into the parentheses.
Okay, so again, you don't have to write this. Algebraically, what we're doing is we have to get rid of those parentheses by distributing in the negative 12. Don't forget about that sign. And so step 2, our statement is going to be 7 minus 12n plus 48. Now I have to go down to a second row here.
Hold up. I gotta see this.
Okay. 7 minus 12n plus 48 equals negative 18n plus 37. It's plus 48 because we're taking a negative 12 times a negative 4. A negative times a negative is a
That
positive.
is-
And then we can do that because of why?
Oh, I know.
The distributive property.
DP.
Okay, the distributive property. In a trial, right, the prosecutor states, this is what you were told in the opening statement. This is what you should believe because of this evidence, right? The fingerprints were on it, something like that. Caught on camera, whoopsie-doo, okay? But we're now working through all of our conclusions with evidence here. Andrea, step 3.
I have a question.
Let's get through step 3 first. We're almost out of time.
Would you use? See, my question relates to step 3.
Go ahead.
So, would adding kind of sums together on a specific side of the equal sign, would that be addition postulate?
Are you talking about combining the 7 and the 48?
Yeah.
Yeah. So one possible step, and here you kind of get to play around a little bit because you can do this in different avenues, right? You've got options. But if we go with the 7 and 48, 7 and 48 is 55. So negative 12n plus 55 equals negative 18n plus 37. What did we do there to combine 7 and 48. Did we use opposite operations or what do we do?
Simple.
We simplify. Turns out simplify is another mathematical reason that you can use to do something. By definition, to simplify means to combine like terms, and that's what we did.
Can I put
We
simple?
simplified. Okay, if you know what simp stands for, but yeah,
Wait, so you can either do simplify or just addition and subtraction?
you can't do addition property or subtraction property because that specifically says you're doing something with both sides. If we're combining like terms on the same side of the equation,
Oh,
that
on the
is
same side.
simplifying. Okay,
Next step.
simplifying refers to the same
Never
thing.
mind. You moved the 12N over.
Next step, we could move the 12n over to get 55 equals 6n plus 37. And because we would have to add 12n to both sides to do that, that would be the addition property.
So we do.
We're doing something to both sides here, opposite operations to move that negative 12n over. We do that by adding 12n. That's the
So wouldn't
addition property. Nick or Finn?
wouldn't it still be a -6 though?
No.
Add one.
Yes, it would. Sorry. Negative 6n. Whoopsie-doo. Don't have time for the song. Carry on.
And then we do.
Then we would subtract 37 from both sides. 18 equals negative 6n. Because of the subtraction property. And finally divide both sides by negative 6 to get a value of negative 3 because of the division property. Woo!
Wait, so N equals
Okay. Yes, Chase. Sorry.
how much N
How
are
do
you
you
do
s-
that?
Would we lose points if we like do them in a different order than you?
What?
Would we lose points if we like do of them in?
No. If you had like move your constant over first and then move the variables, no, that doesn't make a difference.
Alright.
Colin.
You can't say sub property because what if it's substitution?
You would write out the substitution, and typically substitution is just by itself. I abbreviate it because I'm running out of time, but yes, it's the subtraction problem. Okay, Nathan.
I just noticed that I don't know if that's just a coincidence, but there's 4 steps and there's 4 numbers in the first one and there's six different things.
That's
And there's
so
that in
true.
the second one and there's 6.
Purely coincidence.
What do you? Are you
Yes.
serious?
No homework for tomorrow. So long, folks.